All right, we're still there. Good. All right, well, we'll see what happens. All right, so 3, 2, 1, action. Muli Bwanj, Team Mozambique. We are going to go through and just look at your file and pick up a few things that we think we'd like you to think about in a little bit more detail. And before watching this, you should actually watch our common pre-fill video to try and pick up on a few things. So we will just go through and see what we can find that we need to discuss. So I don't see any issues in the S minus module.
Yeah,
so we will go across to the S module. Looking quickly, what we can do is check our US dollar values. These seem believable.
Yep.
So the main thing. Yep, go.
The one thing that I would just ask about here is with the average yields. Because all of the three files that we're looking at are in a similar region, we'd expect most of these average yields to be similar. So maybe just look at these as a comparison between the Zambia and Malawi files, because these are quite different to the values that we've gotten in those.
So we'll send you a little file, hopefully, if we can get time that has that available. The main thing to look at, and this is probably one concern for me, is that maize is quite low on the list, and we know that maize is the dominant crop in Tete. So have a look at those numbers and make sure that this output makes sense, because what we're saying now is Irish potato is 5 to 6 times higher in value than tobacco, dry beans, or maize. So particularly have a look at your Irish potato numbers and adjust them in this S module if you're not convinced that Irish potato is by far more important than any other crop in Tete. Other than that, S minus is okay. If we go to the F module, we have noted here that tobacco is at its production potential. There is no yield gap of tobacco in Tete, which seems a little bit unlikely. So you might want to check these numbers, particularly the tobacco number, to make sure that that statement that there is no yield gap for tobacco is correct in Tete. Moving on to module P minus. We'll just have a quick look here.
So
one thing to be. Yeah, you go.
I can start straight off the bat with the first production constraint here. We're looking at low pH for the soil. And your definition there is low pH is responsible for low uptake of nutrients applied to maize. That's great, but we need a little bit more detail. Why might pH be low? Is it because that's just how the soil is there, or is it because the way that it's been cultivated over time has meant that the pH has gotten low? So maybe just expand a little bit more, and that'll apply across these where you want to go into a bit of detail as to why the particular production constraint is relevant.
I'll go for the second one here. We want to be clear that you are specifically talking about fall armyworm only. So when you answer further, it's not just about suboptimal pest control, it's specifically about the losses that are responsible due to fall armyworm. And we'll have a look in the P module when we get there. Lack of residue retention, I think that's fine.
Yep.
Minimal fertilizer application. Yep.
So I guess the one thing with the minimal fertilizer application, so the definition there, farmers prefer to use fertilizer for horticulture crops. that maybe implies, and this would be a point to expand on, that fertilizers are too expensive to use on crops that aren't horticultural. So that might just be a point of clarification that would be good.
Yeah. And then timely operations. So the definition that you've got here implies that this is specific to disease control. Tropical infectious diseases are prevalent during a rainy, hot season and when labor is needed for weeding. So this definition, it's not clear if it's related to disease control, if it's related to weeding or otherwise, because that may impact on these categories, because that could very easily fall into suboptimal disease control or suboptimal weed control as well. So you might want to think about exactly what you're talking about when you talk about labor shortages. We'll move on to the P module now. And all of these will need to be checked if you change anything in the P- module, because you'll have a new definition that you're applying here. We talked about fall armyworm losses, and that generally is primarily on a maize crop. So what you've said, if we go here, is that 70% of maize in Tete is not affected by fall armyworm, which seems a very high number, because fall armyworm is almost everywhere to my knowledge, especially in Southern Africa. And again, you wouldn't expect fall armyworm. Yep, good. So let's go soybean as the easiest one. Fall armyworm doesn't affect soybean. A lack of residue retention isn't impacting soybean. And they're not fertilizing it because it's a legume. So that's fair enough. We're basically saying that soybean is not impacted by these very much at all, except maybe a little bit of labor shortage in weeding. That's probably okay. For maize, I'm surprised that 50% of maize is not impacted by acidic soils. So this column should really focus on no impact at all from these production constraints. So some of these seem, if we look at maize, some of these you might want to reconsider your values.
A good way to do this as well would be to compare those values between the different crops. So as Brendan was saying, maybe soybean isn't so affected by fall armyworm. Maybe maize should be a little bit more affected. Tobacco, here you've said that it's quite heavily affected. And Irish potato, it's still affected, but not so much as tobacco. So if you think about all of them and go through one by one, maybe this one's more affected, that one's less affected, that might make it a little bit easier to assign values there.
The other thing to consider is the level of certainty. So if you put certain, you're saying that you have the data provided for that line. If you put informed estimate, it means that there is some knowledge or data, but maybe not complete data. And high uncertainty means that you're really not sure and there is no data to support that. So we'd probably expect that there would be a little bit higher uncertainty in some of these and throughout your file. It's okay if that's there, but just consider those three types of definitions that are there. When we look at the results, and this may change with your Irish potato, but what we're seeing is that the biggest production constraints are on Irish potato, and that reflects that Irish potato in this module was by far the most important crop. So if you've changed numbers in the S module, this may change the results that come through in the P module as well. But have a look at these numbers and see if you agree with them. If not, you might have to go back and look at the numbers that you're putting, particularly in the P module. We'll go to the C module now. Now, we'll just suggest that you go through all of these definitions. So for instance, the details of insect outbreak, yield reduction. So we need to know what insect outbreaks are going to be made worse by climate change. Remember that this is the climate change module. So we're already capturing insects. Well, you've said that insects are not, you said fall armyworm is a pest control issue here. So we don't want to count any existing fall armyworm, but you might want to count the fall armyworm that is going to be worse due to the climate. Let's go through each of these and see if we can look at them. So early season water deficit, your unit is millimeters at planting. Generally, well, Mackenzie, you're the units man. What do you think?
Yeah, so here, we've actually put together a bit of some standardized units which are good for the different challenges. I'll just get those now. Yeah. So for early season water deficit, you have 3 options. We can look at the total number of days without rain through the early season. We could look at the number of millimeters of rainfall below the average, or we could look at the longest period of consecutive days without rainfall in the early season. Another thing to consider here is it's good to outline which months you would consider to be the early season. Because this tool is being used over lots of different countries, that can vary between places. So it's good to just specify those here.
So the other thing, when we look at the definition, we're talking about insufficient water. And then you've said insufficient water is leading to mycotoxin contamination. For me, that's not a connection. So think about your definition. The other thing is millimeters at planting, insufficient water, but you're saying more millimeters is catastrophic for insufficient water. So your units are going the wrong way. So I'd suggest that your best unit, based on what we have here, is millimeters below average during early season. And you'd want to put here when the early season is. So you'll need to redo your numbers here to then be millimeters below average. Put the average in here and then, and go from there. The next one is change temperature, seasonal temperature increase, but then you've got heat stress. So heat stress is itself an option to choose. Increased heat events or increased severity of heat events.
Yeah,
that's actually an old category as well. So this is increased temperature, and it sounds like you might be looking at heat events. Go, Mackenzie.
So for this one, if you're looking at increased heat events, the unit for that one would be the number of days above a maximum temperature which you will decide on. And you want it to be a temperature where crops are going to start to be a little bit stressed, or maybe even significantly stressed. So Brendan has just put in there 35 degrees. If that is the temperature at which crops start to be a little bit stressed, then you can think that, all right, maybe for a mild impact year, if you had 5 or 10 days where that were above 35 degrees, there would be a little bit of yield loss. Going all the way up to catastrophic impact where lots and lots of days are above 35 degrees. So have a think about how many days above 35 degrees or another temperature which you choose will cause those impacts, those yield losses.
The next one is flash flooding. So kilograms per hectare is not a unit for flash flooding. The general unit that we would use is days submerged, or what are your units for flash flooding, Mackenzie?
So flash flooding, with this one, you want to make sure, because we have flash flooding and then we also have stagnant flooding. So flash flooding implies that there is flowing water, and that's fine. You can absolutely use flash flooding. And the units for those ones would be the number of flash floods with at least a minimum amount of rainfall. And then the other one would be, for one single event, it would be the millimeters of rainfall in the worst flash flood of the season.
And if we were doing stagnant flooding, what would our units be?
If we were doing stagnant flooding, we would do either the number of consecutive days with a stagnant, or where the field is soaked in one event. So the number of consecutive days for one time where it's flooded, or the total number of days over the season where the soil is flooded.
Excellent. So the next one we're looking at is severe winds causing plant lodging. Number of plants lodging, we'd probably actually look at percent lodging if you wanted to go with plant lodging. I think that's easier than trying to quantify wind speed. So we'll just suggest that you use percentage lodging. And you will need to look at the percentages that would relate here, but often it's, 15%. These are just suggested numbers. You need to do what's right for your location, but these would be in percent form. The next one is climate-induced insect outbreaks. We would generally do percentage yield loss for this unit. Remember, though, that this is about the climate-driven insect outbreak, so you can't double count from the P module on top of that. The next two are total seasonal water deficit and mid-season water deficit. So we've already got early season water deficit and mid-season water deficit. So you may want to consider removing this because you already got that, or putting in a late season water deficit instead, because there's no need to assess early season, mid-season and total season. If you choose to keep it, we would suggest that you would again go with millimeters below seasonal average. And the same with the next one would be millimeters below average in the mid-season. The next one, timing of rainfall, soil loss. So you seem to be talking about erosion here, and erosion is not a climate hazard. It's also not related to the timing unless you're talking about specifically it occurring, for instance, at planting when there is no soil cover, and that's causing it. So we need a definition that would allow us to understand what the climate hazard is, not the outcome. So soil loss is an outcome that's driven by a climate hazard. So is it heavy rainfall at harvest, for instance?
Might be increased rainfall intensity as well, but it looks like you already have that down the bottom. So you need to think maybe that's already captured in Climate Challenge 10 as well. You don't want to double count.
Exactly. And again, if it's timing of rainfall, it would really be millimeters during X period. And that should be unseasonable, that it usually wouldn't rain, but because of the timing it's there. Or if not, you might need to consider a different category there. So excessive water, stagnant flooding. So you've got two floodings here. And your definition is loss of soil fertility due to leaching. So what that means is this one potentially isn't stagnant flooding, it is flash flooding. And then that unit for flash flooding would be, Mackenzie, remind me?
Yep. So flash flooding, we have a couple of options. We can do the number of millimeters of rain in the worst flash flood of the season. We can do the number of flash floods with at least X millimeters of rain in the season, or the height of the worst flash flood of the season.
Okay. So you'll have to work out what your unit is up there. And that would mean then that the stagnant flooding here would be days submerged. And the last one here, storm intensity, rainfall intensity. You want to make sure that that doesn't relate or is not already counted through the stagnant flooding or the flash flooding. And you've also got severe winds, plant lodging. So this is about rainfall intensity. I would suggest that you've probably captured that with the 2 flooding events earlier, and you may wish to remove that. If you were to keep it, you would probably have millimeters in heavy millimeters in 24-hour period. You may wish to consider that 10 is a lot of climate challenges to assess. It's okay to have 5, 6, 7 of those to reduce the workload as well. So think about if you need all 10, and particularly think about double counting. You shouldn't be able to have a climate challenge where you're counting the impact already and then double count it again. Anything further for C-, Mackenzie?
No, that's all good.
All right. It's really important to remember that anything you change here means that all the numbers that you do in this module need to be reviewed. So what we will actually do now is we'll actually remove these numbers because you're going to have to change the C- module. So these numbers, we can probably leave CV, but CO and CI you'll need to redo completely.
Yes.
The question that we have for you here is you should start at 100% and think about the area that would never be impacted by something. So for instance, you're saying that only 10% of maize in Tete would be impacted by an early season drought. That would imply that there is something that maize crops have that allow it to be never impacted by early season drought. Now we know that irrigation is not everywhere in Tete, so we would expect that that number really would be 100% is vulnerable, not 10% is vulnerable. So start at 100% and think about why is it that a particular crop would not be impacted? Is it that irrigation allows it to survive it? Is it that that particular crop is already harvested by late season deficit? But you've got a lot of water shortage issues, and Tete doesn't have huge irrigation schemes. So we would expect that these numbers really would be quite high. All of these crops would be vulnerable.
So even if one crop is maybe not as susceptible to heat, in a severe drought, in a severe early season drought, it is very, very likely that it will still be impacted. So if you think of maybe soybean is a little bit more resilient to water deficit than maize, you would have to really make sure that there's something stopping it from being impacted, even in those very severe years, which would be irrigation, as Brendan said.
So if you take insect outbreak as an example, you're saying that 60% of maize will never be impacted by climate-oriented insect outbreak. So what is it that means that 60% of maize could never be impacted by that insect outbreak? For me, there's very little that you could do. We had one example in Egypt where they put shade netting across, and maybe that means, but that would have to already be there. In Tete, maize is susceptible to insect outbreak, highly susceptible. It's highly susceptible to winds and plant lodging. There's heat stress, there's not irrigation. So lots of these numbers seem very, very low. So you might need to reconsider. In CO, you will have changed these units. So these numbers will be cleared. But it's simply a case of over the next 10 years, how many times would you expect each of these type of events to occur? Not sure how we got 200% yield loss. It's because the numbers must be wrong. But so you'll see that this will be empty and you'll need to repopulate it. Do you have any tips for CO? Mackenzie, no. And the same with CI. This is empty. The key here is Mackenzie's going to explain because he is the wizard at this.
Yeah, so let's look at the first one here. So we have Irish potato, and the climate-induced event here is early season drought. So your average yield over the past 3 years was 20 tons per hectare. Now this value in the non-event year, it's very, very likely that it will be slightly higher than an average yield, or maybe, yeah, slightly higher. And what you need to think about is in an average year, if there was no issue with early season water deficit, what would the non-event year, what would the yield be? So maybe in this average year here, there was a little bit of early season water deficit, well, early season drought, which meant that the yield was decreased a little bit. If we took that away, how much of a yield increase would you have? That's the key to this one. Then we move on to the next one in a mild event year. And you can really ask a question every time because we have prompts here. So for Irish potato, if there was 7 millimeters below average during the early season, what would the yield be? And you have the average yield and the non-event year yield to refer back to.
So remember that it's a single stress removed. So these numbers, so the numbers that you put in across here, they are likely to be different numbers. They are not the same numbers because each of these has a different impact and it has had a different impact on the average yield and will have a different impact throughout. So really these should be unique numbers that come through. When you've done that, go into this See Results module and have a look and see if it makes sense. And if not, you need to go back and adjust your numbers. We'll also record something for A- in a different video. So this is our overview of the things we think you really need to look at in your file. Anything to add, Mackenzie?